The title of this section is called Binomial Theorem, but we're not really going to be doing Binomial Theorem. We're doing kind of a different way of solving. You'll learn more about the Binomial Theorem in pre-calc next year. I'm teaching you like a easier, I don't know if it's easier, a different way of doing it using what's called Pascal's triangle, which is what this thing is going to be when we finish it. Pascal is a mathematician.
All mathematicians are evil.
And he has a triangle.
Chameleon from Rapunzel.
He was a chameleon from Rapunzel, named after the real guy. In Pascal's triangle, you will have numbers. These numbers represent coefficients, the coefficients of binomials that are expanded. So for example, you can take a binomial and give it an exponent. And when you have a binomial raised to an exponent, you have to multiply that by that many of itself. So if you have x plus 1 to the 1, well, there's just one of those, so you're just going to have 1x plus 1. But if you have x plus 1 squared, that's 2x plus 1s that you would have to multiply together. If you have x plus 1 cubed, that's 3x plus 1s that you would have to multiply together. Okay, and if I had something like x plus 1 to the 8th, that would be 8x plus 1s that I would have to multiply together, and that would take a while, correct? Yes, it would take a while. And so instead of multiplying those out together, we have the binomial theorem, or Pascal's triangle, that will help us multiply those out more easily. So before I show you how to do that, first we are going to make Pascal triangle, and to do that, you don't really need these little hexagon things. You can just write like the numbers here, like that. So that's probably what you'll do unless you printed out the notes. So just start with those first couple of numbers, and then I will show you how to keep making more numbers. Why does that look blurry? Alright, so in Pascal's triangle, this is called a column, and in that column, all the numbers will be ones. Now going the other way,
all of them will be ones.
Those will also all be ones.
Oh, I got it.
This triangle can go on forever. It can go on indefinitely. I stopped it at 7. So, in between, how do we get the numbers that are like 2 and all of these guys inside?
2.
So you add the numbers that come before. So 1 plus 2 is what?
3.
And that's what's going to go here. Now you're going to do it again. 2 plus 1 is
3.
And that's what's going to go in here. And so we've created another row of Pascal's triangle.
So then it's
So that'd be 4, 6, 4.
Yes.
You have 5, 10,
14.
10, 5.
Yeah, 5, 10, 10.
You have a 6, 15, 20.
No,
15, 6.
Okay.
7,
And you have a 7,
21,
21,
35,
35, 21, 7. Easy money.
Okay, now do you notice any kind of things?
Pattern.
Anything in general?
There are numbers.
There.
in hexagons.
Yes, they are numbers. What else?
They're numbers.
There's like 2 of the same number next to each other. Like 33.
Okay.
There's like a reflection.
Symmetry is the word you're looking for.
Exactly.
What else?
Column and a pattern or something, maybe?
I mean, the pattern you know already. It's the sum of the previous terms.
Right. So if the whole row is an odd number,
So close.
it's gonna, the middle one's
So if the whole row has an odd number of things, the middle one is going to be a unique number versus if there's an even number, then there's going to be
It's gonna
2
be, yeah.
repeated.
Yes.
What else?
The previous row is half the.
Sometimes, not always.
The previous row.
Not
adds
always, just
up-
sometimes.
The previous
Yeah,
row
1, 2, 3,
adds
4,
up
5,
to
6,
that
7.
front row.
Yeah, there you go.
Oh, that's what you're looking for?
1, 2, 3, 4, 5, 6, 7. Is it going to continue that way?
Yes.
Yeah, because you're always adding 1 and then the previous number, so you're always increasing that column by 1. Okay, in Pascal's triangle, this first little diagonal right here, that is called a column, as I stated before, and that is known as column 0. Okay, that's more important for the binomial theorem than for what we're going to use it for. But that's what it's referred to as. The next column, which is the first column that has numbers in there other than 1, that is column 1.
Okay.
Now going the other way, so horizontally we have rows. So at the very top we have row 0. This would be row 1. This would be row 2. This is row 3, row 4, and 5, and so on. Okay? So horizontally we have rows, and then diagonally that are kind of up and down, those are known as columns. Okay. You can make Pascal's triangle really big, or you can make Pascal's triangle really small. It just sort of depends on what you're trying to expand. So I made it 7, that's as far as we'll need to go today, but you can make it bigger if you want. Alright, so you're going to be given a question that will most likely say to expand a binomial. So you're going to make the binomial, instead of a binomial, a polynomial. Okay, that's why that's in this chapter. So we're turning a binomial to the 6th power into a very long polynomial. Okay, you're going to need a lot of room for this. So the first thing you're going to do is you have an exponent right here, and that's what's going to tell you which row in Pascal's triangle to use. So if it's a 6, then we want to use the 6th row in Pascal's triangle. Okay, those are going to represent coefficients of each term in the polynomial. So we start by writing those down, and you want to leave space in between each term, because we're going to put other stuff there too.
Yes, and
I'm going to like erase the top half of this triangle. Okay. Okay, those are our coefficients. Now, every expanded binomial is going to have a certain number of these and a certain number of these in each term.
Me.
You with me?
X, B, 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 B.
Okay. Whatever this first term is, you are going to raise that to the big power, the 6th power, right here. So you're going to have 6 2a's in the first term. Then you are going to decrease the number of them for every succeeding term. So in the next term, you're going to have 2a to the 5th power. And in the third term, you'll have 2a to the 4th power. And 2a to the 3rd power in the third term. 2a squared, 2a to the 1, and then 2a to the 0 power. Anything to the 0 power is 1. Okay. What about this guy? So this guy, we are going to start from the other end. You're going to have 6 of those over there.
Jesus.
And then you are going to decrease going this way.
Is this gonna be the test?
Yep.
Why?
I have no room.
Why not?
I don't have any room.
Let's make more room.
What's this torch?
Figure it out, guys.
I don't have room though.
Well, problem solve.
But I can't problem solve. I have no room.
Get another piece of
I don't
paper.
have another piece of paper.
Erase.
Okay,
Do it
erase
again.
is dead.
I don't know what to tell you.
Alright, okay, I'm rewriting it.
Now, if you look at each term, so keep in mind each one of these is its own individual term. So, in between the blue coefficients, I'm putting little plus signs so that these look like individual terms. Okay, but if you look at each term, the sum of the exponents is what?
So,
iPad.
6. So look at the first two. So 6 and 0, that makes
6,
5 and 1 is,
6,
4 and 2 is,
6,
3 and 3,
6,
2 and 4,
6,
1 and 5,
6.
0 and 1, 6. Okay, and why is it 6?
Because it's in the 6th row.
Yeah, because we were raising it to the 6th power, and it's in the 6th row. Now, how many terms do I have? 1, 2, 3, 4, 5, 6, 7. So I have 7 terms. I'm always going to have one more term than there is exponent. I don't even really know how to
Exponential?
It's not the right way to say that. So you're always going to have whatever the exponent is, whatever power you're raising this to, you're going to have one more term than that number. So if you're raising it to the 5th power, you'll have 6 terms. If you're raising it to the 4th power, you're going to have 5 terms. If you're squaring it, you have 3 terms. So since we raised our binomial to the 6th power, we have 7 terms. Now the next thing we're going to do is simplify these guys. It's falling. It won't stay. Make it stay. Okay, so now we need to simplify all of these. So I'm erasing a little bit more of my triangle here. Okay, so sometimes you can simplify in one step and sometimes it's going to take a little bit more. For this one, I'm going to simplify in 2 steps. So the first term is a 1, and then 2a to the 6th power. So you need to figure out what 2 to the 6th power is first.
No, that's
Is
fine.
Okay.
Because 2 to the 7th is 128.
So we have 64a to the 6th. And then we have negative b to the 0. So what did I say before about anything to the 0 power?
It's 1.
So that's just going to be 1. Okay. So that first term, if we were to simplify it all together now, is going to be 64a to the 6th. That's our first term.
Wait,
How'd you get 64?
because
I don't know. Nick said it was 64.
yeah.
3 2s is 8, 16, 32, 64.
Aren't you in robotics?
No. Thought you were in robotics.
2048. Anywho,
They do that in computer science.
next we have 6, and then we have 2a to the 5th, and then negative b to the 1. So
32.
6 is 6.
Check this.
That's just the coefficient from Pascal's triangle. What is 2 to the 5th?
32.
Okay. So we have 32a to the 5th. And then is negative b to the
Where are you getting
1,
these numbers from?
2 to the 5th. 2 to the 5th
Huh? Okay.
is 32.
You have to memorize.
Negative b to the 1 power is going to be a negative. That's really all you're taking out of there is the fact that it's negative. When you simplify all of that together, you're going to get 6 times 32 is
It could still be.
186.
180, yeah.
That's going to be negative.
Or is it 188? No, 186.
No, wait.
Yeah, it's 1. No, it's.
No, I was going to say it's like
I know
190, 192. Wait,
Hold up.
Move your finger.
192.
Yeah. I was thinking 64.
I think I was forgetting the 2. I think I was doing
Yeah,
30,
no, it's like-
31 and 6.
Should have given us more room for this.
Wait a second. 12.
This is the most room I can give you. I gave you the entire width of the page. Figure it out, darling.
Yeah, 190.
I don't figure stuff out.
All right,
Plus
that's that one.
add 9.
Next we have 15. We got to do 2a to the 4th. So what's 2 to the 4th?
16.
Okay, so 16a to the 4th.
That's it.
And then negative b squared, is that positive or negative?
Positive.
That one's going to be positive. It's- even exponents are going to be
Because a
positive.
negative times a negative.
Negative b and negative b is going to be positive. All right, so we got 15 times 16.
240.
Positive.
Let's get.
Okay, so 240a to the 4th b squared.
Now is not the time for Olivia Newton-John.
Okay, next one.
Well, every time is.
That's always
So we have 20, we have 2a cubed. So what is 2 cubed?
8.
8, so we'll have 8a cubed. And then is negative b
Minus-
cubed positive or negative?
Negative.
Negative. Oops. So that's going to be a negative 160a cubed.
That's
Because 2 times 8 is 16, and then we got the 0, so 160a cubed. And then b cubed. It's negative because this guy was negative. Next term has a 15.
Number 15.
We have a 2a squared, so 2a squared is what? 4a squared. And then negative b to the 4th, is that positive or negative?
Positive.
Positive. Okay, then we just multiply 15 times 4, that's going to be
Something.
60 a squared b to the 4. No, you wouldn't, trust me. Okay, then we got plus 6. 2a to the 1 doesn't really, we don't really have to do anything. That's just going to be 2a.
Yeah.
Is negative b to the 5th positive or negative?
Negative.
Okay, so
I said
negative b to the 5th. So this is going to be minus 12a b to the 5th. Okay, and then the last one, so you have your Pascal's triangle coefficient 1. You have 2a to the 0 power. Anything to the 0 power is 1.
So it's just maybe.
And this is going to be a positive b to the 6th.
Maybe.
So this is just plus b to the 6th.
No, 180.
We just throw this problem in a pizza cup.
So what you have here, you have 1, 2, 3, 4, 5, 6, 7 terms. That is what you would get if you were to expand this out.
That's it? That's the answer?
That's the answer.
That's it.
What do you mean that's it?
So this is
Come the bomb is tested
this is
tomorrow.
baby handwriting.
No, I think Sam's is worse. I'd agree.
He has an extreme bias.
Actually,
No, I'm serious. Like,
let
just
me
like,
beat all of you. My
straight.
first week having a cast was terrible.
Oh,
Miss Rep knows that too. I had to get someone else to take my quiz, and I told them what to do.
wow.
Seriously?
Yeah, Miss Rep. Do you remember that?
It's my TA, right?
Yeah, it was. You know, it was your TA. I
Who
was
was
like,
it?
"Can you put this down?" I'm like, "That's a hawk."
I wrote the
I
same
looked out
number
the window. I
That was
was
so random. He was
Well, at least
telling
your
a story.
handwriting back to normal. My handwriting will.
It's a
If
school.
I break my arm, oh my god.
Yeah, I was staring that way, then my attention span, I saw
Okay,
the bird.
I set it up. Then you're going to simplify. Anything to the 0 power is 1, so you can just disregard the things that are to the 0 power. Okay, for the first one, you're just going to get x to the 4th. For the second one, you want to make sure that you are doing negative 3 to the 1 power first, and then multiplying by 4, so that's going to be minus 12, x cubed. Here we're going to square negative 3, that's 9. Multiply 9 times 6. Here we're going to do negative 3 cubed, that's negative 27 times 4. And last but not least, we're just doing negative 3 to the 4th, which is positive 81. Now if you look at the signs, what do you notice about the signs of each term?
It changes.
Changes, they alternate. Okay, so the first term is positive, then it alternates to negative, positive, negative, positive. If I make this a plus, what do you think the signs will do?
Change. Whole thing. Whole body.
You're going negative, positive.
Reverse.
Hmm?
Oh wait, if you change which one?
If I
to
change
negative?
this to a plus, everything will be positive.
Yeah.
Because when you multiply positive things times positive things and then you add more positive things, what do you get?
Positive.
Positive thing.
Positive things.
You get negative.
So if it's positive, you don't have to worry about the signs. But if it's negative, you have to make sure that the signs are alternating. Okay? Okay. We're going to skip example 2. We're going to move on to example 3. I don't speak French, so I don't know why I'm doing that.
French is a useless language.
In example 3,
If it's not English, it's useless.
It's
oh
not
my gosh,
English.
stop. I'm recording your ignorance.
It's not English.
In example 3, we're not expanding, okay? It just says what? What does it want?
Expand.
Okay.
Find the quattro.
So, in the expansion of blah 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 to the 7th power, how many terms do we have total? 1, 2, 3, 4, 5, 6, 7, 8. We only want
That one.
this one.
So when you just stop there.
Now, which row are we looking at?
Row 7.
Row 7 is 1, 7, 21, 35, and
stop
so
there.
on. Do I have to keep going?
No.
No, I'm just going to stop right there at 35.
Yeah.
Okay.
That's it? It's just 35?
It's not 35, silly.
To the 6,
Then-
to the 5th, to the 3x, to the 30.
Okay, then we have a certain number of 5x's in there. How many 5x's would we have here?
1.
No.
Six.
You'd have none.
7 here.
6.
Here?
5.
Okay, so here I have 5x to the 4th.
Wow, it's right in the middle.
Okay, then we got 6y. I'm going to count the other way.
Why?
So how many 6y's would I have here?
Whoa, 0.
0.
1.
It's 6y3.
So I'll have 6y cubed. So now all I have to do is simplify that, and you're going to get a big number.
Extra thick.
All right, so
1,000.
first you're going to get 35 because that's the coefficient. Then you have to figure out what 5 to the 4th is.
Number.
Oh, wait, no. You did it wrong. You did it wrong.
Okay. Then you're going to figure out what 6 to the 3rd is.
36 times 6, 12, carry the 1, 6, 196.
And then you got to multiply them all together.
Yeah.
So you're going to take this number, and this number, you're going to multiply them together, and then you're going to get some big
no
number.
calculators. I got this.
I got it.
Oh my gosh,
Where's my
please
TI?
don't.
25 to 16.
No.
It's
30,
4,725,000.
Nope, stop it. 12, 15,
X to the 4th y cubed.
36, 37.
Are you sure about that number?
Suck.
I'm about to tell you the real number in 2 seconds.
Yeah, he's right.
Stop. We're gonna suck.
10, 4, 5, 12. Add all these up.
No,
I just double check.
Stop. We're gonna
10,
suck.
8, 10,
Okay, this is our final answer. This is the 4th term.
3, 1.
4,700,000.
Your vertical translation,
Up and down.
up and down. That'll be on the outside. So after the parentheses. If it says plus 5, it's going to move up 5. If it says minus 5, it's going to move down 5. So those are the things that we're going to focus on when we look at our cubic in that form. We're going to describe the cubic first, and then we will graph it using those things. What is h in this example?
-2.
Technically, it's just the 2. And that is going to make this move to the right 2. So we would have a horizontal translation because of that 2. And this function is going to move to the right 2. So basically, if it says minus, it's going to move to the right. If it says plus, it's going to move to the left. Only on the inside of the parentheses. On the outside, not the case. So do we have a vertical translation? Yes. Does this make it go up or down? Up. So you have a vertical translation that is making your cubic go, whoops, I wrote 2, but I meant 3. So your cubic is going to go up 3. Is there anything that would cause this to compress, stretch, or reflect?
No.
No. That would be something over here, and we don't have that there. So there's none of that. No compression, no stretch, no reflection. So we've described it. Okay, now we're going to graph it. When you graph this cubic, you're going to use those numbers there as your first point. So 2 and 3 are going to be not really the coordinates of your vertex, because vertex implies that this graph would come to some sort of point, and it's not coming to a point. but we can still use those in the way that we use a vertex, in the sense that we would like start with that point and then go from there. So that's what we do with parabolas. We start with the vertex and then we pick points near the vertex. So that's what we're doing here. We're starting with the vertical and horizontal translation as a point, and then we're going to pick numbers close to this for the rest of our points. So pick one number below and one number above. And it's not really, cubics aren't symmetric like parabolas, where if you plug in 1, you're going to get the same thing as 3. So let's see what we get when we plug in 1. So 1 minus 2 is what? Negative 1. Negative 1 cubed is?
-1,
And negative 1 plus 3 is?
2.
2. So when you plug in 1, you get 2. You have a point at 1, 2. And you should know what the end behavior is because it's a positive cubic. So you should know that that end is going down and that the other end is going up, because that's what cubics do. They do opposite end behaviors. Okay, then we want to plug in 3. So what's 3 minus 2?
1,
And 1 cubed?
1,
And 1 plus 3?
4.
So you have a point at 3, 4, which is here. Okay, and all 3 of those points, they look like they're in a straight line. They're not in a straight line, because this is a cubic. If they were in a straight line, it wouldn't be cubed. Can't be cubed and be straight. So what you're going to do is, from this point here to this point here, you're going to kind of like round it out so that it's kind of drifting downwards. From this point to the next point, you're going to round it out so that it's kind of drifting upwards. And then the rest of the end behavior is going to just go in general up, and this is in general going to go down. You could plug in more points to get a more accurate graph. That's where it's going. Probably going a little bit more this way, maybe. Something like that.
Yeah, the 0 is like 0.553.
Something like that.
0.558.
So, do you guys remember how to find the zeros on your calculator?
I just did.
Yeah.
Okay, whip out your calculator and try to do that.
0.558.
Okay, so graph it first, and then to find your zeros, you should go to Menu, Analyze Graph, and 0. Now you only see 1 0. But how many roots does a cubic have? 3. So what does that mean about the 2 that we can't see?
Imaginary?
They're imaginary. Okay, we're not going to find those. We're going to find the real ones. They do exist. Alright, so my calculator says 0.558. Some calculators might round slightly differently. Whatever it is, it is. Okay, so if I'm looking for that 0, I have 0.558, 0. That's the real 0. Also known as, what is a faster way or a more graphically descript way of saying real 0? What else is that point called? We have roots, we have zeros. What else is another word for that? There you go. So another way of calling that point, especially when we're referring to that point on our graph, that's an x-intercept. That's a better way of naming that point because we're talking about it on a graph. So a real 0 could just be a real 0 of an equation, but an x-intercept is specifically where your graph is going to touch your x-axis. We would find them the same way algebraically, which we're going to do a little bit later. In example 2, we still have the horizontal translation that we had before, so it's going to be horizontally translated which way? To the left. We still have a vertical translation like we had before, so this one's going to go which way? Down 11. Okay, and then what's new is we have this guy, and this guy. Okay, those are unrelated. The negative and the number are not related to each other. The negative sign is going to make this reflect, so we're going to have a reflection. The 2 is a vertical stretch. Okay, you can either say a vertical stretch by a factor of 2, okay, or you can say a vertical stretch times 2. I do that because it's faster. It basically means the same thing. Your graph is going to increase twice as fast with the 2 than it would have without the 2. So the y's are increasing doubly fast. That's not a word, I made that up. Okay, so twice as fast with the 2, and that's why it's a vertical stretch by a factor of 2. Okay. All right, so the way I described it in that last example and then in this one, I want you to describe this function and then graph it. You can graph 4, -3 as a point, and then you should have a point at 5, -2.5, and then 3, -3.5. And then we're going to curve and whoop, kind of missed a little bit. Kind of missed it, but something like that.
Bless you, Shay. Dang.
How do you get negative?
So we're going to solve this similar to like how we would just solve a regular linear equation. In general, we want to get x by itself. So I'm going to start with this number. Whatever this number is, we want to move it over there. So we're going to subtract 6 from both sides. So I get -6 equals 3 times the quantity of x minus 1 cubed. Then you're going to
Divide by 3.
divide by 3.
Yay. Negative dose.
Okay, now here's the thing that I told you not to do, because if you do this, sometimes you don't find the imaginary solutions, but in this scenario, we don't care about the imaginary solutions. So what we're going to do to get rid of the cube is cube root both sides. You are only doing this when you're only interested in finding real solutions. If you're interested in finding imaginary solutions, you don't want to do this. You either want to factor the sum of cubes, or perhaps you want to use the synthetic division techniques that we did, but you wouldn't do this. You would do something else. So when we do that, that gets rid of the cubed. And some numbers are rational when you cube root them, and some aren't. -2 is irrational. We don't know what the square root of the cube root of -2 is, but it exists, and it is not imaginary because it's a cube root. Okay.
But it's a negative number. Ah.
But it's a cube root.
Oh.
And 3 numbers make negative numbers, and that's okay.
Oh.
2 numbers can't make a negative number, and that's why we have imaginary.
That makes sense. So now you just add 1.
So now we just add 1.
Equals 1 cube root -2.
Yeah, it's kind of ugly right now, but that's basically your answer, and then your calculator will give you an approximation of that. So I'm going to ask that you put both the exact answer, which is this, and then you can ask your calculator to round or approximate that. So, so I'm going to do 1 plus, the cube root button is right next to the square root button, so it's blue. So cube root of -2. Press enter. So it's negative 0.2599-ish. So if you were to graph it on your calculator and find the x-intercept or the 0, that's what it would give you. Okay. Questions? No questions? Okay, try you try this one here.
What do you mean?
28.
128.
Oh, okay. So did you like multiply or something?
No, I added 128.
Why 128? Oh, you did this one.
Oh.
Oh. That wouldn't be wrong though. Okay, but in ours we're gonna add 8. We'll do both of these simultaneously. Okay, now what?
Times -8.
So up here, you want to multiply by -8 because that's the reciprocal. Down here you would divide by 2.
Down here, you would divide by 2. Oh wow, you do so many, don't you?
Okay, so here we get -64 equals x minus 7 cubed. Okay, after this you're going to cube root both sides. Over here we get -4 equals x minus 7. Down here we get 4 equals x plus 1.
Wait, what are we doing?
Oh, you still get 3.
Just, doing 2 problems at once.
Dang, girl.
Here we're going to add 7 and we get x equals 3. Here we're going to subtract 1 and we get x equals 3.
That's so weird.
Oh, hey.
Hold on.
Coincidence?
I did not.
Actually, it is.
I did not.
Okay.